In this video, we will be looking at a probability question that is asking about a situation where there's no replacement of the objects when chosen. So for example, you have a bowl that has 3 blue chips, 4 green chips, and 5 red chips, 12 chips altogether. You were asked to draw one chip, don't put it back, and then choose another chip. The question is, what is the probability that both chips are different colors? One of the easiest ways to solve a problem like this is to create a probability tree diagram. So we begin with writing out the 3 possible outcomes for the first pick. The chip can be blue, green, or red, with probability of 3/12, 4/12, and 5/12 respectively. The difference is on the second pick. You have to account for the fact that one of the chips is now missing from the bowl, so the probability changes. When a blue chip is picked first, there are only 2 blue chips and 11 total chips. When a green chip is picked first, there are only 3 green chips and 11 total chips. When a red chip is picked first, there are only 4 red chips and 11 total chips. Since we know that the probability question is, we can find the outcomes that are only relating to that question. In other words, we don't have to complete the whole tree unless it's needed for a different question. So we only need the outcomes for which the 2 are not the same color. But using the complement principle, it would be less work to find where the 2 are the same color and just use those. So the event of blue, blue would be 3/12 times 2/11, or 6/121. Green, green would be 4/12 times 3/11, which is 12/121. Red, red is 5/12 times 4/11, which is 20/121. So the probability that they're the same color is 38/121. So 1 minus that, which is 83/121, which is approximately about 69%, is the probability that they are not the same color. Tree diagrams help to visualize the outcomes and to record the probabilities of each step in the experiment.